So hello guys, I'm back with another video and this time it's Bachelor of Statistics Honors Admission Test 2007. Multiple choice test, time allotted was 2 hours, there were 30 questions and this is the first part of our video. We'll cover the first 5 questions, okay? So let's start. X is an irrational, A, B, C, D are rationals, so that Ax plus B by Cx plus D is a rational. Which of the following is true? See, X Cx plus D will also be an irrational number. Why? Because C has been multiplied by an irrational number, it makes it Cx an irrational number, and you add D to it, which again has no effect. So what we do here, we multiply both the numerator and denominator by the conjugate of the denominator, and then we'll get a rational number for sure. So starting from here, we see the solution. See, ax plus b by cx plus d, we multiply both the numerator and denominator by the conjugate of the denominator. We get this ac x square plus x into bc minus ad minus bd by c square x square minus d square. Now this is a rational number, and for this to be a rational number, x has to be of the form of a square root of a non-perfect square, and this BC, the coefficient of x, that is an irrational number, should be 0. So BC minus AD should be 0. So BC equals to AD. Okay. Now number 2. Let z equals to x plus iy be a complex number which satisfies z plus z bar z equals 2 plus 4i. Then y equals plus, then the options are as follows. The solution to this is z equals x plus iy, z bar equals x minus iy, z plus z bar into z equals, see, iy and minus iy get cancelled, so x plus iy plus x minus iy equals 2x into z equals x plus iy. On computing this, we get 2x square plus I into 2xy, so LHS equals 2x square plus I 2xy, RHS equals 2 plus 4i. Comparing both the LHSs and RHSs, we get for the real part, we get x equals plus minus 1. When x equals 1, y equals 2, and when x equals minus 1, y equals minus 2. Okay, moving on. The third question. Suppose a, b and n are positive integers all greater than 1. If a power n plus b power n is prime, what can you say about n? See, this is a good question. See, what will happen here, the logic we will be applying here is that a power n plus b power n is divisible, is a composite number only if and only if n is an odd number. Any number of the form a power n plus b power n is always divisible by a plus b if n is odd. Okay, so let's see the solution. If suppose there are two types of evens, one even is this one. If n is even and not a power of 2, then we get a power n plus b power n equal a power 2 power p multiplied by q plus b power 2 power p multiplied by q, where n equals to a power 2 power p multiplied by q. Now this 2 power p has been multiplied by q, where q is an odd number. Now we know that as stated earlier, x power m plus y power m is divisible by x plus y only if m is odd. Okay, put m equal to q here, an odd number, and x equals a power 2 power p and y equals b power 2 power p. We get a power n plus b power n equals to n was 2 power n was 2 power p into q, and so the same here, n was 2 power p into q. Okay, now this a power 2 power p is nothing but x, b power 2 power p is nothing but y. So some integer power an odd number plus some integer power the same odd number is always divisible by x plus y. So x plus y divides a power n plus b power n. So a power n plus b power n is not a prime when the power n is of the form 2 power p multiplied by some odd number, or is not a pure power of 2. Okay, Now if n not equal to 2 but a power of 2, we cannot factorize a power 4 plus b power 4 or a power 8 plus b power 8. We won't get any factors. So a power n plus b power n would be prime. So our correct option would be the integer need not be 2 but must be a power of 2. So B is our correct option. Okay. And for how many real values of p to the equation x square plus px plus 1 and x square plus x plus p have exactly one root? See what we do here, we subtract both the equations, okay, because then the x square terms will cancel out and only we will be left out with the only one value of x, okay, and that is on exactly that would give the exactly one common root. See, 1 minus 2 will give you px plus 1 minus x minus p as written, x into p minus this on simplifying this you will get x minus 1 p minus 1 is 0. If p minus 1 was 0, then you will get infinitely many roots, but we want only one single root, so x minus 1 will only be 0, so x equal to 1. From that, putting x equal to 1 in any equation, you get p equal to minus 2. So only one value of p will be there. So 4, the answer is B. Only one real value of p will give you exactly one root. Okay. Fifth question. The limit n tends to infinity 1 plus 1 by n squared to the power 8n cubed by pi sine pi by 2n is. Okay. See, this limit is of the form 1 plus 1 power infinity. If you look at it closely, it is 1 plus a 1 plus a very small number to the power infinity. Okay. Okay. To the power of a very large number, that is infinity. Okay. Now this can be written as, this will be written as e power the index, that is 8n cubed by pi sine pi by 2n into 1 plus 1 by n square minus 1. Okay. Now this is because the limit is of the form 1 power infinity. Okay, as stated earlier. Now this is a formula that you put whenever you get a limit of the form 1 power infinity, you subtract, you assume the limit to, you equate it, the limit to be e power the index of the term tending to infinity multiplied by the base 1 plus n1 by n square and subtracting 1 from it. Okay, this is a formula we use for solving such equations. Okay, so this will give you 8n cube sine pi by 2n into 1 by n square, and this would further give you 8n by pi sine pi by 2n. Now sine pi by 2n is again tending to 0, so we multiply pi by 2n both the sides, and now it becomes sine theta by theta, where theta tends to 0. So this limit is 1, so this will be 1, and pi cancels out, 2n cancels out 8n, and we get e power 4. So this was the end. Thank you.